So the other demo that we're doing with inferencing, so you can imagine at the edge, I've got my host that I'm doing some type of inferencing on the CPU using OpenVINO. And in this demo, all I really wanted to show was how do I put an L7 reverse proxy on, how do I put that on the ARM cores of the IPU and then actually use it to offload something like TLS. Future versions might extend that to say, hey, I will also want to enforce open authentication, or I want to do some other type of security function. But the idea here is that I don't have to, again, tax my CPU to do those functions. I can offload them down to the IPU and achieve exactly what I want to do. So in this case, all of these instances are using our P4 implementation around OVS. And we create some bridges on the ACC to bring in the physical traffic. It all gets terminated at NGINX running on our ARM cores. And then, of course, NGINX then will load balance that traffic on the back end to the VMs that are running on the host. We use that by creating a bridge in the host, and we just have a representer connected to that bridge that's available on the ACC to direct that traffic to. So inferencing request comes in. We have the FX, or the fabric processor rather, redirects all traffic to the ACC. We see that there. We authenticate that and do our TLS unload. And by the way, because not only does our fabric processor have the inline crypto, but the ARM processor also has look-aside crypto acceleration as well. And so the next step of this demo then will be to take that TLS and accelerate both the symmetric and the asymmetric pieces of setting up the session and offload that to the look-aside crypto. And then we service the request here on the host. So let's take a quick look. We did this demo with F5, and what this allowed us to do was to demonstrate that the IPU is an excellent way. It can be packaged along with either an appliance that has a Xeon host, and we can again put all of this either fleet management type of capability down onto it, or we could have again this authentication authorization capability there as well. You see a similar picture here. Let me just kind of accelerate through this, and then I want to save just a few minutes here for questions at the end. So again, we're sending a picture into the inferencing engine using just a simple Python gRPC client. That picture gets sent along the path, and basically the inferencer will then tell us, hey, what am I looking at? Am I looking at a dog? Am I looking at a cat? That type of a thing. So this is a golden retriever, and it comes back to the gRPC. So let's get to the interesting part of the demo, which is, I always push the wrong button. Try this again. So I went ahead, you got 4 windows showing here. I'll make this really simple. The bottom left is the client. The top left up here is the IPU. Over here we have the host itself. And then down below we have the VM. And what we're going to do is just do a TCP dump on all of them, right? So as a packet comes through, we can actually see it appearing in all those different places, right? And as it gets forwarded along. And so that's what this demo here is going to demonstrate and illustrate as we send a packet. So the packet gets sent here, and we end up seeing, TCP dumps along the way. You'll notice that the TCP dump, hitting the front side of the IPU, right? It's encrypted. You got the TLS encoding, and then when it hits the backside of NGINX and it gets sent on up to the VMs, everything has been offloaded and things work just as you would expect them to. So in terms of future work that we want to do here, obviously you asked the question. We've got single host, but we also could do east-west load balancing in the FXP, right? So as inferencing requests are coming in, we could use the onboard compute to determine kind of what is the load happening with the VMs in the local host. We could actually then just immediately drop or redirect traffic using the hardware accelerator to another node, right? So load balancing across the cluster. We can use the look-aside crypto, right, to accelerate the TLS. We want to transition a lot of this to more of an L3 model because, again, in Kubernetes, if you're talking about containers, or even things like KubeVirt, they're using more of an L3 model. And so moving things to L3 simplifies everything. And then finally, what we've been showing here is inferencing on the Xeon host. Eventually, for smaller models, we may actually be able to bring OpenVINO onto the ARM core and imagine using inferencing for packet analysis, right? So as my packets are coming through, I can actually use the AI engine to classify not only the packet, but the contents in that packet and do all of that on the IPU as well. So that's going to be some future work that I'm going to be applying to this same type of use case. So with that, I think I came in under about 3 minutes that we had left, and so I will take any questions that you have.
In terms of the sales cycle,
Okay.
how often is the IPU, I guess, bundled with other Intel offerings, and how often is it, purchased, say, standalone?
Sure. Well, there's several places that we're going to want to obviously bundle it. As we think about, either our own GPU offerings, right? The IPU is a perfect north-south type of scale out arbiter, right, for accelerating traffic, as we do a scale out cluster. So that's a perfect example of one. If we think about our OEM providers that want to provide maybe like a out of the box hardware end-to-end solution for enterprise Kubernetes or things like that, right? The IPU can then be bundled in with in those types of cases where we have applied a personality to the IPU. So it's out of the box, ready to use for just all of your standard enterprise Kubernetes workloads. So there's a lot of different cases where, and I really kind of call these more like our solution packs, right? How do we apply a particular persona or behavior to the IPU to meet that kind of end-to-end stack behavior? So that's what we're looking at right now.
How many customers are you seeing that are looking at like Kubernetes on bare metal, but they really want the function offload of what you guys can provide in the IPU to get the maximum capacity utilization out of the platform?
So I'm going to draw on not only my experience at Intel, but my experience that I've had at a lot of other places. Most people that are running Kubernetes are actually deciding to move to running Kubernetes on bare metal. A couple of reasons. One reason is, traditionally, if you ran something like Kubernetes, you had both a VM management orchestration as well as your container management. And unfortunately, that's going to cause those two to conflict, right, in terms of bin packing and all the things that you need to do as an orchestrator. But now with things like KubeVirt, right, we have a lot of customers that are wanting to move to a single orchestration plane for both all the lift and shift VMs that I want to put in there, and I'll containerize them as a KubeVirt VM. And I also have all my new, greenfield cloud native type stuff running in containers, and I've got a single control plane that can manage both of those, and doing it on bare metal is just more efficient. So everybody from fintech to telco, wanting to run 5G containerized on bare metal to manufacturing and retail, right? Imagine, your favorite fast food restaurant having point of sale, right? Cameras, whatever they've got, all running over a similar Kubernetes, or bare metal type solution, right there on premise.
And you guys are really the only solution that you can look at for that NFV offload function to still keep things.
That's exactly right. So we can extend. So in those cases, right, where we're putting something like Kubernetes on bare metal at the edge, the nice thing is we can extend all that storage back into the cloud, or even to an edge storage provider, right? And in terms of where it lives, we really don't care because we can accelerate that, with our built-in NVMe capabilities.